I got 3 A's in maths for my A-levels and you can too. Here's how.
First off, let's take a look at my actual results. As you can see here, I have gotten an A for physics, an A for chemistry, an A for combined mathematics, I have gotten 78 for the common general test, and I have gotten an A for general English. If you look at the top here, you can see my district rank is 52, my island rank is 667, and my Z-score is 2.0820, which is quite good. In this video, we'll be talking about mainly how I got these marks, and additionally, at the very end, there'll be a segment where I talk about the Z-score, what it is, how it works, and how you can find how good you are based on your Z-score. I got these results by self-studying for about 8 months with various different resources. I used resource books given by the government, I used other resource books, other tutors by other people, past papers, and many other resources. All of them will be linked down in the description. As for my method of study, I believe I've isolated the 3 main points that contributed to my overall success. It should be noted before we continue that these methods may not work for you. However, I do encourage you to at least try them out and see how they work for you. My first point is to study with breaks. I personally never study for any more than 30 to 40 minutes straight. When I study 30 to 40 minutes, I would then take about a 10-minute to 15-minute break before going back to studying, and then I would study another 30 to 40 minutes and then take another break and repeat the cycle. The basic idea here is that your brain has a limited attention span. You will only remember the things that you learn for the first 20 to 30 minutes or so. After that point, your memory ability and your efficiency of learning will gradually decrease. Due to this, in order to stay in the maximum learning intensity region, I took breaks in between studying. I would never study for any more than 30 to 40 minutes. I know some people that study for 3 hours, 4 hours or even longer straight continuously without breaks. And while that may work for some people, in general it's probably not such a good idea. I'm not discouraging the people who learn like that to not learn like that. However, I personally believe that you should not commit to a task directly without any breaks for any more than 30 to 40 minutes if you want to learn something. My second point is to have a study buddy with you. A study buddy is a peer or maybe potentially a parent that you could have with you, where you could discuss with them the topic that you're learning and exchange ideas, exchange perspectives, and get a better understanding of the subject. For this, my father greatly contributed. He would sit and potentially discuss certain things with me, or maybe share perspectives, exchange perspectives, give ideas that maybe I wouldn't have thought of, and ask questions. I could even teach him. And by doing that, I believe I gained another advantage. You see, in order to teach something, you yourself as the teacher need to know more than the student who you are teaching is expected to learn. The reason for that is if the student asks you a question, you need to be able to answer it. If the student doesn't understand something, you need to be able to share a different analogy, a different perspective or something like that in order to better teach the student. And in order to do that, you yourself first need to know more about that subject. You need to understand the subject thoroughly before you explain it. In addition to studying, you could also do things like at the end of the day, try to summarize what you learned so far. Maybe you learned something, he learned something, and you two can compare with each other what you learned. Maybe try to teach the other person what you learned so far. You could also try doing practice problems together. And the advantage of that is that each of you would see the problem in a different way. You would have a different perspective on it, and due to that, you might solve it in a different way. If you'll see how the other person solves it, you could get a better understanding of the problem itself, because you can only see the problem from your fixed viewpoint. I would not recommend getting more than 2 study buddies. You would ideally have just 1 person or maybe 2 people. If you get more people, then it tends to get more chaotic and you could also go off topic. Due to that, I would recommend that you have just 2 people or a single person as a study buddy. You could compare notes with that person, you could discuss the topic with that person, share perspectives, change ideas, and give different new interpretations of the knowledge. My third point is to do past papers. Do a lot of past papers. Do past papers all the time. Do past papers even before you finish completing the syllabus. I personally started doing past papers before I even touched the syllabus. The reason for that is that when you look at a past paper, you can see the type of questions that they ask. You can see the structure of the questions that they ask. And more importantly, if you look at the marking scheme, you can also see the type of answers that you're expected to provide. The advantage of this is that you can see the structure of the answer you're supposed to provide, and you can also see specific key points in the answers that you're expected to give. And using that, you can then structure your way of thinking in order to properly answer the questions that they're asking and make it more likely that the examiner will give you marks. An additional point on marking schemes, make sure when you use a marking scheme, you are using the marking scheme that is provided by the government. It is usually available on the Department of Examinations official webpage. If you use any other marking scheme, be aware that there can be a lot of errors in those marking schemes. I personally have found tons of errors in marking schemes that are not provided by the government. I have also found a bunch of errors in the marking schemes provided by the government. However, they are far less than the marking schemes errors that are not from the government. Furthermore, in these marking schemes specifically, you can also find additional points that may not be there in other marking schemes, such as perhaps sometimes teachers' notes, and other times corrections that have occurred, and other times just more detail. So due to that, I would recommend that you always use the government given marking scheme. If not available, then you can resort to as a last resort to other marking schemes. However, I would still recommend going with the government marking schemes. For my overall study plan, what I would do is to study 5 days of the week, and in each of those days I would study in 40-minute sessions. As I said, I would study 3 40-minute sessions in the morning time and 3 40-minute sessions in the afternoon time. That would give us 6 total 40-minute sessions for a total of 240 minutes or 4 hours. In addition to that, on some days, I would cut some of those and instead do exam papers, either to do a couple of questions, a single part of the paper, or an entire paper. I would then mark that paper, check what I got right, check what I got wrong, re-review what I got wrong, and continue the process. As for subjects, I would rotate the subjects each day. On one subject you would have one day, on the next day you would have a different subject, and so on. I continued this process for a total of 8 months, starting in February last year and ending right before the exam. In total, I used about 6 months for the total syllabus coverage, and after that all I did was papers. And by doing that, I achieved the result that I got. So that's going to be all for my method of studying. You can try it, see if it works for you. Let's now move on to discussing how Z-scores work. Z-scores have to do with this graph here. This graph is what we call a normal distribution. You do not really need to worry about what the y-axis as in probability density is or what the x-axis is representing. You just need to understand the fact that as we change the Z-score, what this is representing is the variation of the likelihood that you have that given Z-score. We can see here, for Z-scores close to 0, there is a higher likelihood of you getting that Z-score. In fact, at 0, there is the highest likelihood of you getting that Z-score. As we move away from 0 in the positive direction, you can see for larger and larger values of the Z-score, we are getting lower and lower probabilities. Our graph is going down. This means that it's less likely to have a large Z-score. Similarly, if we look in the inverse direction, as we get to more and more negative Z-scores, once again we can see that the height of our graph is reducing, meaning that the overall probability of getting this kind of Z-score is also decreasing. The basic idea of this curve is to represent the fact that most people will be average. We can understand how this graph is representing what most people are average is by looking at these 3 equations here. The first equation is the most important as it tells us what the Z-score is. A particular Z-score is equal to a particular value minus the average divided by the standard deviation, where mu is the average, or more specifically it's the mean, and sigma is what we call the standard deviation. So here, this could be your result. You could have a certain mark, let's say maybe it could be your mark in physics, your mark in mathematics, your mark in chemistry, or it could be your overall total mark. What this is representing here is basically the concept of an average, as in the average mark, and what this is representing we will look at. Going down, we can see that this bit here, mu, as in the mean, is representing sigma x divided by n. Sigma x here is meant to represent the total sum of all of the individual results that all of the people in our population got. Basically, we measure every single person's value, we add them all together, and that is what sigma x is representing. N here is representing the total number of people. So if you divide sigma x by n, you are essentially taking the average mark of all of the people. Let's now move on to standard deviation. Standard deviation is the square root of x minus mu squared all over n. Now in this case, we can see that x minus mu can be interpreted as the distance between a reading x and the average reading mu. So this bit here is representing how far away a particular reading is from the average. If we square it, what we then get is the unsigned distance squared of any particular point and the average. When we sum all of those together, now we get the total sum of all the distances of all the points in our distribution from their central tendency, the mean. When we divide that by n, now we are getting the average distance squared between any particular point in our distribution and the average. And finally, when we square root it, what we get is the average distance between any particular point in our distribution and the average. This thing has a special name. This kind of operation where you square something, add them all together, divide by the number and then square root is called a root mean square. It is a form of finding the average. In this case, we are using it to find the average distance between all of the points on our distribution and the central tendency, the mean. This quantitative standard deviation essentially tells us how far apart or how spread out we should expect the data to be. Now, if standard deviation is the expected distance from the mean and some particular value, if we take our real distance between the mean and a particular value as in x minus mu and divide that by the expected distance, what we are getting is a fraction which tells us how far along our real deviation from the average is compared to what we would expect. So, if this deviation is a large positive number, it means you have gotten a result which is much higher than you would expect on average. If it is a large negative number, it means you've gotten a result that is much lower than the average that you would expect. If it's close to 0, it means that your result is quite average. This z-score can be translated into a percentile, as in, if you have a given z-score, let's say z-score of 2, which would mean you're somewhere over here, z-score of 2, we can figure out how much of the population has a score that is lower than you, as in, how much of the people scored a mark that is lower than you. That percentage is the area under the curve that is before your given z-score. So if we just color this in, we can see this area here is representative of how much of the population scored worse than you. And this area to the right here is representative of how much of the population scored better than you. Now, if you are a very high scorer, you will be far to the right, meaning that very little of the population will have scored better than you and almost everyone in the entire population scored worse than you. Similarly, in the inverse case, if you have a really negative z-score, it means that you scored better than almost no one and almost everyone scored better than you. So in essence, what you want to get is a very positive z-score. You want to get a z-score that is like 2 or 3 or so on higher. You cannot actually get z-scores like 3, for example, because those z-scores are the z-scores that the top people get. If you get a z-score of around 2, it means you are close to the very top. For a matter of fact, my z-score 2.08 is at about the 98.1th percentile. This means I have scored better than 98.1% of people. It also means on the inverse case that 100% minus 98.1% or 1.9% of people have scored better than me. So generally, you want a more positive z-score. You don't want a negative z-score because that means you've done worse than average. You want a more positive z-score. If you have your z-score and you want to calculate your percentile, I'll link a couple of online calculators down in the description below that you can use to calculate how much of the population has scored worse than you and how much of the population has scored better than you. So that's going to be all for my explanation on z-scores, and it's going to also be all for this video here. I hope you enjoyed, I hope it was informative, I hope you take something away from it. If the methods in this video worked for you, you can thank me when the results come out. If they didn't work for you, well then I can't really say anything for that. So that's going to be all for this video. Thank you for watching and goodbye.